Radio. Hey, kia ora, guys. Sorry I'm not there at the moment. My kids have been vomiting. Um, so yeah, sorry. But yeah, I've got your tests. You should hopefully be getting them back today. And I thought since I'm not there and can't go over it with you in class, um, I'll have a go at doing it here online, and you guys can kind of follow me. Use each other as well. So overall, I think everyone in the class maybe got every question. There might be one that nobody got. So, help each other out. That's probably way easier than listening to this video. You right, love? Hang on. Okay. Sorry, I've got some sort of thing there. All right, so let's have a look at how you guys did. So, yeah, there was lots about cats. Question number one. Those of you who didn't use Pythagoras, I wrote in huge letters somewhere on it, Pythag. Okay, it was a Pythagoras question. There are no angles involved. Okay, if it's only sides involved, then it's Pythagoras. The answer, I think, was 60 centimetres. Okay, nice, easy, achieved question there. And if you have a wee look at the answer schedule, and I'm going to put a copy of this on Teams for you so you can have a look. See how it says allow CAO? That's correct answer only. So that means that if you didn't show any working at all, you actually would have been okay with just 60 centimetres, okay, for an achieved mark. I think they probably only do that pretty much once in a paper. All right. Question number two, or the second question. Oh, yeah, Isaac. So, yeah, it was one about Isaac. I didn't make these questions up. It just happened to be an Isaac. So, this was where you're trying to figure out how long that length there, Y, was, with this maximum of 90 centimetres in length for the highest vertical post. All right, and right. So you're going to put on here. First of all, just notice you've got to read the words. Okay, make sure you've read what this is saying about. So once he has enough wood to make the scratching post a bit bigger, but he wants to add on to the first design without changing what he's already made. So it's given us two little bits of information down here in the picture, but actually we know that what he's already made includes that 75 centimetre. Oops, I'm on that 75 centimetre length there as well. So pop that in. Okay, you know that that's 75 centimetres. So the question is, he's got this maximum of 90 centimetres to make Y if he has this gap here of 25 centimetres. So can he do this? Can he make that other vertical post? And if not, suggest how far away from X he should put Y. So that's the excellence part of this question, keeping the position of X the same, because remember, he doesn't want to change what he's already made. So there are a couple of different ways that you can look at it, and a few of you did this in a couple of different ways, which was dandy. You could just first of all use Pythagoras. What are we wanting to figure out if that's 90? So we could use Pythagoras to work out how far X is if you wanted to. So you could do 75, so what is it, X squared equals 70, whoops, that's a 5 squared minus 45 squared. And I'm just using my calculator on my phone, which is really kind of dumb and annoying, but let's try it. 75 squared minus 45 squared equals square root of that. Oh, we know that. It was 60. Oh, my goodness. So X is 60. We worked it out in part A. So, yeah, the question is it going to be possible for that to be 90? They're similar triangles, aren't they? So you could approach it in that way, working out that they're similar triangles. So let's compare them. So we're saying really that 60 compared to Y is going to be the same as 45 compared to 70, yeah, because that whole bottom length there is 70, and 45 is the length of just that smaller triangle. So let's try that out. What have we got? 45 divided by 70 is that, and I've done mine kind of upside down, sorry guys. So you end up with 60 equals 0.6428 y. Okay, so I've just turned that into 0.6428, and then I've times it by y. And so now I'm going to divide 60 by all of that. divided by 0.6428, and we get 93.34 for y. Okay, so that's going to be centimeters, and that's 2 decimal places. Okay, do these things carefully. If you did just that much, that was worth, let me just check, just that much, you found the angle or finding h. So there we've actually found h or y in this case. That was worth a merit mark. Okay, just doing that. So well done, quite a lot of you got that. But then the question was, and of course with that, to get the merit mark, you really should be saying something about this situation. So of course he's got a maximum of 90 centimeters. Apparently we're going to need 93 centimeters for y. So no, it is not possible for Isaac to make this design. So therefore the next question is, how far away should he put y? How far away from x should he put y? So we're kind of saying that I think this 25 centimeters here, it ain't going to work, and we're going to need something a little bit shorter so that we can bring y in a little bit closer so that it is less than or equal to 90 degrees, okay? So yeah, you could do this, in a few different ways, really. If I'm thinking about this, I'm thinking, okay, I need that to be 90. I'll use a darker pen. I need that to be 90. Let's do it over here. Oops. I want y to be 90. I want to find this length here, what this length here has to be. So I might call that z. Okay, that's the thing that I now want to find out. So I could use my 90, and I can use my 60 because that has to stay the same. X is still 60 centimeters tall, so that first vertical post. So let's compare 90 and 60 and just use our similar triangles again. And then we can say, okay, that we're going to compare our whole distance, okay, so for the 90, so this larger triangle, this guy here, to describe what's going on for the horizontal length there, it's going to be 45 plus z, isn't it? Yeah, 45 plus z. And we're comparing that to the smaller triangle, which is just 45. All right, so there you go, 9 over 6. It is just 1.5, isn't it? Yep, 3 over 2, or 1.5, equals 45 plus z divided by 45. We can now multiply, so you can see where our algebra comes in handy. Multiply 45 by 3 over 2. So 1.5 lots of 45. Yeah, we'll use my calculator for that. Tip it on its side. 45 times 1.5. So I've got 67.5 equals 45 plus z. And then we can minus 45 off that. And that gives us 22.5 centimeters for z. Okay, you could actually have used trig a little bit for this too if you wanted to do that instead. Whatever way you wanted to really to find a length. But yeah, so now we can say, okay, Isaac would want to keep that distance from x 22.5 centimeters rather than 25, and that means he'd have that length of 90 that he can use. All right, sweet. So yeah, excellence mark. You'll have a little T in the corner there if you've got an excellence mark. You'll have a little R if you've got a merit mark. You'll have a little U if you've got an achieved mark. Okay, so those marks are there in the margins. Okay. Oh yeah. Hey, it was really cool, and I think Molly, you might have been someone who did this. Really cool to see some of you in these using highlighters. It was really cool to see because there were a couple of different shapes going on, and quite a lot of you got to a point where you got stuck. So we've got this wheel. I went through these answers well over a week ago, so I just have to remind myself. We've got the legs of the structure 90 degrees apart, so there. If the angle between the hamster's body BD and the opposite end is 58, so they've told us this wee guy in here being 58. Find the angle between AE and AD, so that's X in the diagram. So that's this guy here. Okay. Watch out, and I've put comments on that, just watch that you are labeling your angles correctly. Your little angle sign should be going in front, and the middle, so for example, where X is, we can call that E, A, D, like that, okay? The A goes in the middle, and you're heading out to that one. I think one of you is quite confused about labeling angles. There might have been a couple of you, so I will be back on Wednesday, and I'll be able to talk to you guys then as well. So yeah, angle EAD is the one that we're trying to find. So we're going, okay, how on earth are we going to find that? Lots of you straight away you could see, oh, okay, we've actually got cyclic quadrilateral there. So brilliant. That means that angle EAB must be 180 minus 58, which is 122 degrees, and then you put your lovely explanation in. You must have the explanations. Some of you, and I've written that on there, you'd worked out some cool things. You just scurried away on your diagram here and you'd written all sorts of angles and stuff with no reasons. I can't give any marks for that because this is geometric reasoning. You have to show the reasons, guys, okay? Yeah, so there are a couple of you that would have got quite a lot, much better marks, actually, if you had just explained your reasons beside everything you're doing. If you can do it step by step under the diagram, even better, okay? That's what we should be doing. It needs to be logical and in order as well, not just scattered along the diagram. Okay, so we've worked out that AEB is 122 degrees. So let's put that in A. I'm just going to use a different colour pen. So EAB we've got is 122. And again, this is where your colours can come in a little bit handy. Right, what can we do next? So we know what those are. You've got, yes, you've got your centre here. And so the next step that a lot of you took was that, of course, this must be an isosceles triangle. So triangle BOD, so you can put your triangle symbol there and then BOD is isosceles because of the radius. Okay, coming from the centre, those two radiuses are equal. So therefore, you've worked out that angle OBD is the same as angle ODB, and that both of those must be 45 degrees, and that's also because of angles in a triangle being 180. Okay, I'm not going to write all the examples in this, guys, okay? Not examples, the reasons in all of these. They're also in the answer schedule, so you can look at them. So you've then worked out that those are 45, so let's pop them on. We've got 45 degrees there. We've got 45 degrees there. Now, even if you'd only gotten this far, and some of you did only get this far, and then you got a little bit stuck, if you have a look at the marking schedule, getting the 122, okay, finding one relevant angle with reasons, or you found the final answer without reasons, that was worth an achieved mark, okay? So just finding any one of those was worth an achieved mark. And then this whole thing is a merit question, so if you actually did find X and you had at least one valid reason, I think that's quite generous, really, then you'd get your merit mark. So this last step is where we got a bit stuck. And what was it in the end? It's our thingy shape. It's our thingy at the centre, wasn't it, that we use? So I'll use a different coloured pen to do it. So if I get pink here, you'll notice something, okay? We know the size of an angle in the centre of our circle here. If you've been told the size of an angle that's in the centre, then there's a bit of a chance, a relatively high probability, that you might need to use that. And of course, we have a rule for the angle in the centre, and that's that the angle at the radian, or the angle at the centre, is 2 times the angle at the circumference. So can we use that here? So here's our angle at the centre here. You think about that rule. Remember that thing I showed you in class, because we have our, I'll just use another pen, we have the classic one that looks like that they have in our Walker Maths book. Okay, that's quite obvious. But remember I showed you that little, whatever it is, GIF, I don't know what they call it, that thing where you can move that around. And so actually it might, instead of looking like that classic shape, it might actually look like that for example.